Hey guys, welcome back to another lesson. Today we're going to be talking about operations with polynomials. It's a little bit of a glare right there. I tried fixing it, but because of the position of the camera and how the whiteboard's being reflected with all the windows in here and the lights, I apologize for that, but it does say polynomials. Today's lesson is going to be a little bit of a review from what you did in Algebra 1. I'm not going to dive too far deep in a lot of different details because that's the stuff that should be familiar to you, okay? But I'm still going to break it down. I'm still going to break it apart so that way you can at least see some of it. I guess I contradicted myself there a little bit, didn't I? Oh well. First things first. When we're using operations with polynomials, there are some things we have to work on before we get to the actual polynomial part, okay? And we actually do some operations here. Let's talk about monomials real quick, okay? To simplify a monomial, and we're talking about one term, mono, right? When you're simplifying, you got to make sure there's no powers of power. Now, when I'm talking about that, that means this. Okay? If you see something like that, you should simplify it. Each base appears once. So in other words, I don't have this. Okay? See how A, I can't see that, huh? See how A appears twice? I need to simplify that. And then that'll be my final answer. All fractions are in simplest form, so if you had like 16 over 4 a squared, you should have 4a squared, okay, when you simplify it. And then no negative exponents, so a to the negative 2 power, we should flip it, okay? We shouldn't leave it as a to the negative 2 power, okay? So when you're simplifying, you got to keep these things in mind. If this is still being shown in the problem, you can go a little further and reduce. So this is going to require you to have some knowledge on some exponent rules. And hopefully this will start clicking with you when we get through a couple problems. Okay, first problem. We want to simplify this guy because clearly we have some issues here. We have multiple bases, or not multiple, we have multiple bases, but we have the same base appearing a couple times. We have a negative exponent shown twice. Not quite reduced, right? Let's show like an expanded form first. Expanded form. Okay, so let's go ahead and figure out what's going on here. A to the negative 3rd power is 1 over A times A times A. The negative just implies that I have to change the position of it. If it's already in the numerator, then we're going to put it in the denominator. If it's in the denominator and it has a negative exponent, then we put it back up in the numerator, okay? And A to the 3rd means there's 3 A's. Now, this next section, A squared is A times A. B to the 4th is 4 B's being multiplied to each other, right? And then the last one, C to the negative 1 power, is 1 over C. I just took this guy and expanded it outward. Now, can you see what cancels out? I have 3 A's here in the denominator. Oh. And I have 2 A's up here in the numerator. So I can cancel those guys out, but 1 A still remains. Okay, I accidentally marked that. I have 4 B's in the numerator, doesn't cancel out with anything else. And I have 1 C in the denominator, which doesn't cancel out with anything else. Putting it all together, I have 1 times 4 B's times 1 again. I have B to the 4th left in the numerator. In the denominator, I have 1 A here and 1 C, so I get A times C. So if I were to simplify this expression, it would look like this. Now you're probably thinking, okay, what if this was to the 100th place, 100th power? And what is this to the 50th power? Okay, now you're not going to want to have to draw these out, right? So just based on observation behavior, we can see what we're going to do here just by using exponent rules. So let's go ahead and do that. So for step 2, or no, method 2, I'm sorry, let's take a look at just the exponents and see if we can't get to the same conclusion. All right, first step. I can see that we have multiple of the same base here. When you have the same base, you add the exponents. What's negative 3 plus 2? We get a to the negative 1 power when we add them. B to the 4th is the only b's there, so we're just going to leave it as is. And then we have c to the negative 1 power. That'd be my first step. Second step, take care of the negatives. A and c both have a negative exponent, which means they're going to go in the denominator. B to the 4th is positive. It's going to stay in the numerator. Therefore, I get b to the 4th over a C. Okay, I get the same answer, one using the rules of exponents, one where I just expand it and cancel some stuff out. You can probably see which one's more efficient, huh? Okay. All right, first example. Not too bad, right? Okay. I feel like something's going to crash. There's something behind this board that's preventing it from being moved, and I'm afraid to look behind there. All right, example 2. Okay, we're dividing, and what I'm going to do is I'm going to expand this first. So n squared is just n times n, right? 2 n's. N to the 10th power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, means there's 10 n's there on the bottom. By canceling things out, I can see that 2 n's up top can cancel with 2 n's on the bottom. What's left is 8 n's, huh? So the answer would be 1 over n to the 8th power. Now once again, is that efficient? Not quite. We can kind of see what was going on here. If I have like bases, so that was the expanded. Let's look at the exponent rules, okay? If I have like bases and I'm dividing, you would subtract the exponents. So this is really, when I simplify it, it's n, and then I'm going to subtract the exponent 2 minus 10, okay? When I do that, I get n to the negative 8th power. And because it's negative, that means we're going to find the reciprocal of it. So we have 1 over n to the 8th. As you can see, I get the same answer, huh? Nothing really changes there, which is pretty cool. A little bit more efficient when you know the rule. But if you forget the rule, do like a small example in your head or off to the side. Like, okay, if I expand this out, oh, I can see what I'm doing now. If I subtract the exponents, I get the same result. Good. Let's do one more. Let's see. Okay, let's do this guy. And let's erase this. That's going to get in the way. Okay, so now we're going to raise this entire fraction to the 2nd power. Expanded, it looks like this. It would be 3a cubed over b to the 4th times 3a cubed times b to the 4th. Okay? Multiplying these using some exponential rules and just based on what we just did previously. 3 times 3 gives me a 9. A to the 3rd times a to the 3rd would be a to the 6th power. B to the 4th times b to the 4th would be b to the 8th power. There's my final answer. Okay. Now, with exponents, if we use those rules, look at what's happening here. I went from b to the 4th, when I raised to the 2nd power, it became b to the 8th, right? We're multiplying these, aren't we? That's what it's coming down to. A to the 3rd being raised to the 2nd power, giving a to the 6th. Once again, multiplication. So if I do that, you can see clearly that when I distribute that 2nd power, I get 9a to the 6th over b to the 8th. I get the same answer. Okay? Now obviously, if this was to the 5th or 6th power, you're not going to want to expand that out. You want to use just that exponent rule. All right? But I just want to make it very clear. You can get to that answer. If you're not sure what the rule is, well, expand it a little bit. Okay? Even if this is to the 10th power, expand it twice. See what the pattern is. Say, oh, now I remember what it is. I have to do this. Okay? You shouldn't have to memorize when it comes to mathematics. There's always ways of getting to a formula. There's always ways of getting to a rule or a law or whatever it is you're looking at. And getting to that point, remembering just how to get to that point, I should say, is you're using your mind a lot better. Memorizing doesn't mean you actually know it. It just means you know how to recall it. Make sense? Okay. Alrighty. So what do you think? We're done? Go home? No, we can't do that. We just simplified some monomials. Let's go ahead and talk about some polynomials. Okay. Do you hear that? Hear how there's a little bit of resistance? There's something behind these boards that's preventing it from moving nicely. And I don't want to know what it is. It's going to be a mystery for you guys at home. Okay. So let's talk about polynomials. In fact, I'll tell you what. Let's put it right here. Poly means many, right? We have many monomials, many single terms. So we're going to put those together. But to be a polynomial, okay, this is important. All right, all exponents are negative, I can't spell that, non-negative integers. Okay? That's very important here. So non-negative integers are those exponents. Okay? Let's take a look at an example. Okay? Determine if it's a polynomial, I'm going to abbreviate with poly, all right, and state the degree, which we'll get to if it's a polynomial. Here's my first one. Okay. Think about it. Are all my exponents non-negative integers? No, it's not. Can you see which one it is? And your eyes are probably going to it, right? This guy. Little side note, okay? Little math doodle over here. If it's an exponent, I'm sorry, if it's a square root, I should say, it's the same thing as me saying c to the half power, okay? The denominator is telling me the type of root, it's a square root, 2. And the numerator is telling me what power it is underneath here. If I had a cubic root, it would be c to the 1/3 power. If it's a fourth root, that's the same thing as me writing c to the 1/4 power. Now let me change it up here. What if I said this would be a 2 right there, okay? Let me just erase this. So if I put a 2 there, then this would be c to the 2/3 power, okay? Remember, denominator is just the type of root, numerator is what power is underneath that. Does that make sense? Now going back to this, if I were to rewrite it, okay, I could see clearly that this is not a polynomial. So not a polynomial, okay? So this exponent is not a non-negative integer. Okay, it's a fraction. Isn't going to work. Okay? c to the 4th would work, but not to the half power. Can't happen. Okay? Just a classification system right now. Okay? All right, let's try another example. Okay, let's look at this guy. And let me erase this over here to have some space. Determine if this guy's a polynomial. And looking at it, I'm going to say it is a polynomial. And I apologize, this doesn't look like a fraction. Here we go, 3/4. Okay, the reason why it's a polynomial, if I look at the exponents, they're all non-negative integers, right? Okay, so it passes the test. Yes, it's a polynomial. Okay, remember, I'm abbreviating. Yes, it's poly. For anyone whose name is Polly out there, there you go. You got mentioned in the video. Now, the degree. Okay, what you do is you go to each monomial here. Okay, so let's look at this guy. The degree would be the highest altogether. Adding all the powers together, that's the degree. Okay, and then we pick which one's the highest. Now for this guy, 16, we don't worry about that. The p-value, the variable is what we're looking for, and the degree is 5. So for this part of the polynomial, the degree is 5. Now, let's look at this guy over here. I have two variables. I have two exponents here. So I'm going to add them together. So 2 plus 7 gives me 9. So the degree for this monomial, this little part of the polynomial, is 9. Okay. Now, which one has the largest? This guy. So I'm going to call this polynomial that it has a degree of 9. Okay, so you got to pick the highest value there. Okay. Okay, makes sense? And this is, like I said, it's just a classification system. It allows us to identify a polynomial based on some characteristics. And then we can use those characteristics to group them, okay? And use that grouping system to solve some more complicated types of problems, okay? And come up with some methods for it. Like, okay, what do we do if degree 9 polynomials came up? Are there some characteristics that we're seeing, or are there some things that we can use for it? Okay? But right now for this video, that's all we need to know. Last example. Okay. And this isn't technically the last example. We got a little bit more to go, okay? We're almost done now. Determine if this guy's a polynomial. Well, it's not. You see why? Right here, right? We have a negative exponent. That's not a non-negative integer, is it? So this guy would be not a polynomial. We have a negative exponent. Okay? So it does not work. What do you think? So far, so good? I think so. Yeah? I'm just assuming that you're saying yes. And I'm going to say, okay, sounds good. All right. Now, we simplified monomials. We classified what type of polynomials we have with their degree. Now we're just going to go ahead and put some operations with it. We're kind of building our way up to it, aren't we? Almost done, guys. Okay. So now let's simplify. That is the instructions for these next couple examples. There we go. Now, don't be confused by parentheses. Just like complex numbers, we're just identifying it. There's this guy's a polynomial and this guy's a polynomial. Okay? Just want to be very clear with that. This subtraction symbol, you better be careful, right? What I would do is distribute this little -1 throughout the entire thing, and then start combining like terms. I have 2a cubed plus 5a minus 7. Distributing that -1 throughout everything, -a cubed plus 3a minus 2. Sorry about that. Now we combine some like terms. We have a 2a cubed and a -a cubed. So how many total a cubes do we have? Well, 1. That's all we got left. I have a 5a and a 3a. Add them together, I get 8a. And then I got a -7 and a -2. I get a -9. Okay? Now what's interesting is that when I add polynomials together, I'm getting a polynomial, huh? So could we say that that entire grouping, that entire set, is closed? It's a closed set? What do you think? Think about that, okay? If I'm adding two polynomials together, do I get a polynomial every single time, or don't I? Something to discuss about, okay? Something to think about, okay? Let's try another one. Another example. Okay. And once again, The parentheses are just there to indicate that we have two polynomials. That's it. Now notice I got a subtraction sign here. This one's a plus sign. Do I have to worry about negative signs in this case? Not really. So I can really remove the parentheses and just combine like terms. 4x squared, negative 2x squared. I think it's a 2x squared, huh? Negative 9x, negative 5x would be negative 14x. And then we have a 3 and a negative 6, so we get a minus 3 for that guy. That's it. Be careful when you combine like terms. Because this is a 4x squared, this is a negative 2x. Wait, to the fifth? No, that's a square. I'm sorry. I have no idea why my hand did that. That's a square. I apologize for that. But when I'm combining these, it's not like negative 2x to the fourth. We're not multiplying, right? And the addition and multiplication, a lot of times people start switching. Okay? When you're adding things, the exponent stays the same. You're just changing the coefficient in front. When you're multiplying them, you're still changing the coefficient in front, if there is one, and you're changing the exponent. Okay? Careful. Just be careful. All right, last example. To finish this up, and yes, this is truly the last example. I promise you that this is. I just have to find it. There we go. Okay. And I'm going to put it right here. Grand finale. And just to let you guys know, the idea of this video is to review the fundamentals when it comes to exponents and polynomials when adding, subtracting, and multiplying. Are there more complicated examples that we could do with this? Absolutely. But I want to make sure you understand the foundations because that will help you figure out the more complicated stuff. Okay? Now over here we can see that we have a multiplication just by distribution. We're going to distribute that negative y throughout the entire process. Negative y times 4y squared. Break it apart. This is like a negative 1, right? So negative 1 times 4 is negative 4. Y times y squared is y to the third power. Okay? See how I kind of broke that up? Next part. Negative 1 times 2 is negative 2. Y times y is y squared. And then for the final one, negative 1 times negative 3 is a positive 3. Y times, well, there's no y's over here, so we're just going to be left with 1y. And there we go. That'd be my final result. Okay. The homework, you'll see how it gets very basic, and then we start increasing the number of terms, and it just increases in terms of just time, I should say. Not complexity, not so much difficulty, but as long as you get the fundamentals, you should be good. All right? So that's the intro, operations of polynomials. The next lesson, we'll start talking about division. And there's two types of division we're going to do with that. So until the next lesson video, I hope you guys are having a good day, and I will see you guys next time.